Hello, my name is Luis Martinez, and I'll be presenting one of Team 14's project ideas for senior design. This project is involved with the FIU EPS lab and is about food, energy, water systems. The goal of this project is to develop an optimized irrigation system that maximizes vegetation yield while also minimizing energy consumption and environmental effect. Some objectives we have for this project are to use sensors to monitor conditions in real time, develop software to process and interpret that sensor data, deploy a swarm of remotely operated valves and pumps to control irrigation flow, and control that swarm using an algorithm designed to meet the project goals. Some constraints we have are that the sensors, valves, and pumps need to be as cheap as possible in order to maintain cost-effective scalability, and that due to them existing out in the field, they must be able to communicate directly with each other and the server, wirelessly, and without internet connectivity. The prototype we will be developing for this can be made using DH22s for basic low-powered temperature and humidity readings, and then that data can be sent to an MSP430 or Arduino Nano microcontroller that acts as the server, and from there software would need to be developed in order to process and interpret that raw sensor data, and an algorithm will also need to be developed that sends out the appropriate control signals based on the results of the data processing. Thank you.
Hello, my name is Stephen Tolbert, and this is our Group 14 Quick project here. So we're building a model for collision detection on the bucket trucks, and the goal is to do this purely with visual data. Some of the objectives and constraints that we want to meet here. So we want to make a cost-effective method that ensures that the operator is safe, and we want to make sure that it's quick and easy to deploy across the entire FPL fleet. By the end of this project, we want to be able to deploy a model, and some of those constraints, it has to be less than $500, and the model must be deployable directly on the truck without the need of internet, since the connectivity out in the field might be low. Some of the concept development here, so how we actually make a system like this. So we're going to use a Raspberry Pi and an OpenCV camera. So this allows us to actually do the computations on board without the need of connecting to the internet and using endpoints to perform the inference. This is kind of unique compared to other safety systems, since we're not going to use radar or LiDAR systems. We're just going to be a purely visual-based model. And then the how would you implement in practice? So you'd have them both connected to the 1224 battery of the truck. Then we'll have some waterproof container that this is all contained in, and if the algorithm senses a collision is imminent, it will sound an alarm through a speaker system to let the operator know. Thank you.
Hi, my name is Vicente Rosado, and this is our idea for an AI drone for our project, for our senior design project. So we want to create a drone that is able to cut palm trees. What we will do is we will attach a saw onto a drone, and we'll program the drone to, instead of cutting directly into the tree, it will spin around the tree and slowly slice away at it in order to cut down the trunk. This will allow the drone to, not only will it not need to push into the tree and thus require an excess amount of power, it will also be able to reposition itself into a position where the tree will not fall onto it once the trunk falls. The limitations for this project, of course, would be the cost of building the drone, and also just how much power will we need in order to handle the recoil of hitting the palm tree.